Hello everyone. I'm going to give you one more example for the power function call. Recall that in the previous video, I mentioned that positional arguments should always come before the named keyword arguments in a function call. When you have all the arguments as named keyword, then the order of the arguments need not be the same as the order of the parameters included in the function definition. For example, I can take this failing function call and convert the second argument into named keyword argument. Why exactly is this function call failing? That's because we have 2, which is a positional argument, coming after the named keyword argument of exp equal to 3. I'm going to copy this function call and I'm going to convert the second argument into named keyword by saying base equal to 2. Observe that this time the function call succeeds. We are getting 2 to the power 3, which is 8. The power function has parameter ordering as base and then exponent. We are still able to call the power function by passing 2 named keyword arguments which have the switched order. I'm going to move to the slide deck and we are going to learn the rules for filling arguments into parameters. Here is an example function declaration. You have the def keyword followed by which you have the name of the function foo. In computer science, a lot of examples will be using the names of foo and bar. The foo function has 2 defined parameters which are x and y. Observe that the parameters are separated by a comma. The parameter y has a default value of -1 and then finally you have a colon which completes the function definition line. Let's assume that we are doing some manipulation with the variables x and y inside the function definition. Here is an example invocation for foo function. This particular function call contains only positional arguments. How can I say that? That's because the arguments of 99 and 100 here don't have any parameter names associated with them as part of the function call. Whenever you have positional arguments, the arguments are going to line up with the corresponding parameters. So argument 99 will go into parameter x and argument 100 will go into parameter y. Rule number 1 is that Python always fills in positional arguments first. Following that, it will fill in named keyword arguments. Here is an example function call which contains only named keyword arguments. How can I say that? That's because each argument has a corresponding parameter name as part of the function call itself. When you have named keyword arguments, you're already mentioning which particular parameter the argument value should go into. For example, the argument 100 will go into the parameter x here and the argument 99 will go into the parameter y. Finally, Python will fill in the default arguments. Here is an example function call for foo which only contains one argument. That argument is positional, so it's going to line up with the parameter x. Since we don't have a second argument as part of the function call, the parameter y will take the default value of -1. If we did not have a default value defined for the parameter y, then this particular function call will crash. That is because in Python, you're expected to pass the exact same number of arguments as the number of parameters if there are no default values. Let's go through some sample problems from today's lecture worksheet. Please pause the lecture video here and download the PDF or the docx version of the worksheet. I've already downloaded the docx version. We are going to go through add function here. So we have the def keyword, then the function name which is add. We have 2 parameters which are x and y. As part of the function definition, we have three lines. Lines 1 and 2 are calling the print function to display x and y. As I mentioned before, you can use the print function call for extensively debugging your code. The final line returns the computation of x plus y. Let's go through sample function calls for the add function. I'm going to go through problem number 1 here. Here we have one argument which is positional. So 3 is going to line up against x. We don't have a second argument for the parameter y. So Python will crash. Let's go through problem number 3. We have two arguments which are positional. So 4 will line up with x and 3 will line up with y. Since we have two arguments corresponding to two parameters, the function execution will succeed for problem number 3. Looks like I wrote down the values in problem number 2 instead, so I'm going to quickly correct that. Let's go through problem number 4 next. We have three positional arguments. 3 is going to go into the parameter x, 4 is going to go into the parameter y. So what do you do with the value of 5? You cannot do anything with it because there are only two parameters. So Python will crash in this case as well. You need to have exactly the same number of arguments as the same number of parameters. Let's go through problem number 6 here. This is a tricky one. What do you think will be the value inside the parameter x? Pay close attention to the fact that we have positional arguments here. Python will always fill in positional arguments first. So positional arguments line up with the corresponding parameter. 7 will go into the parameter x here. What do you do with the second argument? You're getting x equal to 6. You've already filled in the argument of 7 inside the parameter x. So Python cannot make sense of what this second argument is supposed to be and it will crash. Let's go through problem number 7. Problem number 7 has three arguments. You have two positional and one named keyword argument. The positional arguments will line up with the parameters. So x will be 7 and y will be 8. So what's going to happen to the third named keyword argument? You've already filled in the argument for parameter x. So Python will once again crash in this particular case. I'll let you go through the rest of the problems for the add function here. Let me do one example for the say function. The say function contains three parameters which are word, t and end. We have default values for t and end parameters which are 1 and empty string. You can imagine adding print function calls here to display each of the parameters. I'm going to go through problem number 13 here. We have two arguments. The first one is positional, so it's going to line up with word. So I'm going to fill in the string ha inside word here. What's going to be filled in next? If you were thinking t, then that was not correct. Recall that you need to always fill in named keyword arguments before default arguments. So you'll fill in exclamation point inside the end parameter here, and then finally you'll fall back to using the default value for t because you don't have a corresponding argument. So I'm going to fill in 1 for t here. Please make sure to go through the rest of the problems. One thing which might be useful for you is for you to go through the problems first by using your computer keyboard, and then you can copy the function definition and paste it into Jupyter and test the function calls to confirm whether you had the correct mental model about each of those function calls. Do make sure to get practice by going through the function calls without using a Python interpreter first. I'm going to switch back to the slide deck and we can talk about modules. Recall that modules are nothing but collections of functions which are similar along with variable names. There are going to be 4 different classes of modules. The first one is something which is called as built-in module. The built-in module functions can be used by default inside your program without requiring any sort of import statements. Examples for built-in functions would be print function, input function, length function, type function, and so on. You can Google built-in function list in Python 3 and that will give you all the possible built-in functions for you to use. The second category of modules are the pre-installed module. An example would be the math module. For a pre-installed module, you'll have to use the import statement to import the module. Recall that we have covered one way of going through the import, which was from math import star or from math import square root. Once you perform the import, you'll be able to use the functions and variable names defined as part of the pre-installed modules. The third category is installed modules. For example, recall that during the Python 3 installation via Anaconda, we installed the record class module using pip3. The command for that would be pip3 install module name. Once you install a particular module, you'll be able to import that module and use the functions defined as part of that module. Pip refers to Python package index, which enables you to download various modules which are available for you to install on your laptop. The fourth category is something which is called as the custom modules. Turns out that it's very easy to create our own modules in Python. Any .py script can be used as a module. We are going to go through demo first for the dog module and then we'll go through a demo for the cat module. Let me go to my browser window and I'm going to go to the code link as part of today's lecture. I already have it opened here. Notice that you have a dog.py file. Pause the lecture video here and download dog.py file. Recall that you shouldn't right click here and click save link as. Instead, you should left click here and right click on raw and click save link as. I'm going to save dog.py in the same location that I had my notebook file so that I can use the module there. Let me switch over to my Jupyter Notebook session. Observe that we have a new file now which is dog.py. You can open this file using idle editor or alternatively you can just click on it and that will open the file in Jupyter Notebook session for you. You can click on edit in order to edit the particular file. For now, I'm going to remove these lines and we'll come back to this later. Let me save the current version and I'm going to use a split window approach so that we can look at dog.py and also use it at the same time. Let me move my Jupyter Notebook to the left hand side here. Alright, so let's first import the module. I'm going to use the same import style as I mentioned before. I'm going to say from dog import star. Notice that I used dog and not dog.py. You need to only use the name of the program, which is dog here. Once you do that, you're going to be able to call the speak and the fetch functions here. So let me call the speak function. So the dog says bark, 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 bark here. And then let's call the fetch function where we are going to get the return value as stick. So let's try to capture the return value of both of these functions. So I'm going to say speak val equal to speak, excuse me. And then I'm going to say fetch val equal to fetch. And let's try to display speak val and fetch val. Observe that nothing got displayed when I displayed the variable speak val. Let's try to print it. The reason as to why we got nothing is because speak val has an assigned value of none. None is a special type in Python which indicates that a particular variable has no value assigned to it. When you initially assign a value to a variable, for example by saying x equal to 1, you're initializing the variable to a value of 1. The default value which is stored inside this speak val variable is none. That is because when you don't have a return statement included as part of a function definition, Python includes an implicit return none statement. So you have an implicit return here which is going to return none. That's the reason for seeing none value inside the speak val variable. So let's display fetch val here, and we are going to see the value as stick. That's because inside the fetch function we are returning the string stick. So printing a value and returning a value are very different things. We are going to learn about the difference between the both as part of the next lecture video. I'll wrap up this video here.